There are a few methods for the lock object that you need to know and you might use in certain situations. I want to explain to you where you would need to use those. First of all, you've seen the lock and the unlock in the previous video. Fairly simple. It acquires the lock and it releases the lock. The thing that I have found to be very handy is the try lock option. So what the try lock does is it tries to get the lock, and if it doesn't get the lock, it doesn't just hang around. So it acquires the lock only if it is free at the time of invocation. If it is not available, then the method will immediately return with the value false. This is handy when you know that you might have to wait for a long time, and you also know that if you don't get a lock, there are other things for you to do. So here is an example when the lock is doing a try lock over here, and then when it gets the lock, only then it works on something. If not, it performs something else. This is useful when you have like an infinite loop where you need to do something, and if the lock is not found, then there are other things for you to do. All right, so let's say you had inside over here. Let's skip this. I'm just going to write some example code over here. So let's say you had while true, and then in each iteration you need to do something. All right, so here what you can do is I'm going to do a if lock, or let's call it L dot try lock. So this is going to return, try lock is going to return true if it has acquired the lock. And now here I'm probably going to do like a this dot increment. So it's in a safe place where it is, it's only one thread that's working on it at a time. I'm going to do this dot increment, this dot decrement, and then else I have to do something else, do something else, and then once that is done, it kind of goes back into the while loop and then it repeats this. So this is a pattern that I have used a couple of times when working with these locks. The thing to remember though is, of course, you need to release this. So again, just don't release it directly. Just put this inside a try block and then release in the finally, so that there is a guarantee that no matter what the exception is, it is still going to get released. So here I'm going to do a L dot unlock. So this is a very common pattern. You have an infinite loop. You have something else to do in the meantime, and then after that's done, again, go check, hey, can I get the lock again? No, I'm going to do something else, and then can I get the lock again? And so on. This is a common pattern which is enabled by try lock. All right, so that's one thing. The next thing I want to show you is the interrupted lock. So if you go back to the beginning over here, it says lock interruptibly. What does this mean? This means that it is going to acquire a lock only if the thread hasn't been interrupted. We've covered what interrupt is, right? It's that thread dot is interrupted flag that indicates whether somebody else has tried to interrupt this thread or not. So what this does is it acquires a lock only if the current thread is not interrupted. It acquires a lock unless the current thread is interrupted. And otherwise, and if it gets the lock, it's going to return immediately, right? If the lock is not available, the current thread becomes disabled. It's going to wait for the lock to be acquired. So similar to what you've already seen, but it's almost like you have an additional if condition, right? If the lock is available and the thread is not interrupted, only then you get the lock. It's very handy. So there is an additional try lock with a time. So it's basically going to be like, I'm going to try, but then I'm not going to just quickly try and exit. I'm going to wait for some time. If it doesn't get that lock within the time, then it again returns a false and then it moves on. The last method is the condition, which is interesting. I haven't personally used this, but it's important to know what this is, all right? So what the condition does is it actually returns a new condition instance that is bound to the lock instance. So what the condition allows you to do is say, I want something to wait or something to proceed when some external criteria is met. So when some other thing happens, then I want something to happen. Or when some other thing is not a certain value, then I want something to wait or something like that. So that's a condition. You can say, I want this thread to wait until there is some element in my array. I want this thread to wait until this value becomes 0, some external condition. So you can create this condition instance and say when it should wait and when it should wake up. There is a signal method which indicates when it should wake up, and there is an await method which indicates when it should wait. So what you can do is you can create a new condition and say, I want this lock to be bound by that condition. So you're basically saying, let's say you want a lock to be bound by when there is an element in an array or not. So you define a condition instance that does the await and then the signal for when that element is in the array or not. And then you can say, I want this lock to be bound by that array. So when the condition.await is called, the lock will be released. And before waiting, when the wait is done, it reacquires the lock. So it's basically an ability for you to say this lock is dependent on an external condition. I'm not going to go into this a lot because this is honestly something that I haven't used a lot. But if you really want to use it, I definitely recommend checking out the Java doc for this thing. So this is the condition. You basically bind your lock to a condition and have that condition, whether it's true or false in a way, to influence whether the lock is acquired or not. So this is the lock interface. There are multiple implementations of the lock interface. One is the reentrant lock that we talked about, which is similar to the synchronized block. Reentrant basically means that when a thread acquires a lock and there is somewhere else another lock, it doesn't have to acquire it again. It already has that lock on that reference object, so everything is good. So it's basically the same thing. Thread is executing this reentrant lock, which is what we did over here. We had a reentrant lock here, and we did a l.lock. Now this thread is executing, and somewhere else in that same thread it encounters another l.lock. Does it mean that it has to get the lock again? No, it already has the lock. So it's going to be like, hey, I already have it. It's going to continue executing. So that's the benefit of reentrant lock. There are other locks for read-only operations and write-only operations, which is what these implementations are. What this affects is the behavior of the lock. The semantic of the lock is unaffected. The semantic of the lock, see this l.lock and l.unlock, is the interface method. What changes is basically the implementation, the instance that you assign to this lock object.